And I believe we're live. We're live. Yes, numbers going up, both
Super.
on Zoom and on YouTube. So welcome, everybody. Feel free to say hi where you're joining from in the chat. Welcome, Mark, Alistair. Great having you guys.
Thanks, Luca. Nice to be here with you.
And yeah, we'll take a couple of minutes to let people roll in before we get started. The usual, this is being streamed on YouTube. You'll get a recording emailed to you tomorrow, so don't worry, don't go crazy on note taking. Chat's disabled. Is it? Let me test it. Test. Works for me, Nicholas. Are you sure? But great that you found the Q&A feature. You can also use that. And in fact, if you guys have any questions throughout it's mute for attendees. All right, I'll figure that out in a second. Thanks for letting me know. But yeah, so if you have questions, then the Q&A seems to be the only option this evening. Feel free to drop your questions there as we go through. Mark and Alistair will go through a 25-30 minutes type of presentation, and then we'll open up to Q&A. But if you have any questions, we'll try to work them into the presentation as well as we go through them. So super interesting topic today, something quite different than what we normally have. So quite excited to have you guys, and I think we can get started. I'll hand it over to you. Disappear, shut up, and go and try and figure out this weird chat thing. So over to you.
Awesome. Thank you, Luca. This is pretty exciting, actually. So I'm Mark Barry. I'm the co-founder and chief product officer at Enclave. And I'm joined this evening by my colleague, Alistair, who's CTO at Enclave as well. And thanks to everyone who's given up their time this evening to join us. And I hope you find the talk interesting. I think a big thanks to Luca and the rest of the team at Human Intech for organizing these events. And yeah, let's get started. So this talk is about secure connectivity, and I'll explain what I mean by secure connectivity. So I think this covers a range of topics, from things like developers getting access to Kubernetes clusters from home, but worrying about their IP address changing. There's privileged access to management systems, back-end connectivity, and hybrid multi-cloud networking. Perhaps you're migrating to the cloud, or maybe you're operating in cloud. There's also things like remote access to private applications and workloads. Think GitLab, Mattermost, other internal systems. Maybe you're working with third parties, sharing access to APIs, databases. Anything that doesn't really belong out on the public internet is what I mean when I'm talking about when I say secure connectivity. But often keeping those systems private and while using the public internet to access them means that we have to make some changes to our network. And so really, I guess this talk is more about change and the specific changes that we need to make to arrange that private connectivity. And this is what this first slide is about, is really all the changes. I really want to call this work that doesn't add value, but the trouble is it kind of does add value because it gets us to our desired outcome, albeit eventually. And so instead, I'll call this change that we have to do yak shaving. And for anyone that hasn't heard the term yak shaving before, it's simply a term that represents a situation where you set out to do a thing, and then you found you had to do something else, which meant you had to do something else again and finish that, and so on, until you found yourself shaving yak or some other unrelated activity to the first thing that you set out to do. And that's really what these micro adjustments are. Every time the business needs something different, then there's a network micro adjustment. But if you think about it, the most stable systems, they don't really change. All other things being equal, change is actually a great catalyst for failure if you don't carefully manage it. And so when we're implementing change, we have to be careful that we transition from one known working state to another. And the more changes we make, the more likely we are to open the door to things like, oh, I forgot to close an access on the network, so I made things too permissive by mistake, or I need to log what change I make today so that in 6 months' time, I can still understand the context behind that change. And maybe if we're under pressure to make change happen quickly, maybe we end up taking shortcuts like IP, any rules, or we might just inadvertently break something because the system was hard to reason about because it was also complicated. And so particularly with a network, I sort of think of this as translating a business requirement into a technical configuration, being able to preserve the assumptions that you make there and then, and eventually get to a known good state again after you've made the change. And in terms of the network, it's all because of the IP address. All of those micro adjustments that we have to make to the network simply allow us to get packets from one place to another safely. And it sounds simple, but I'd argue that's actually the root of all of the complexity in our networks, because the IP address actually today kind of means two things. It means the location, the deliverability information associated with the packet. Where is it going? Where did it come from? But all too often, it also means the identity. Who sent the packet? Who's receiving it? What's the access control list? What's the network security group? But I'd argue this is wrong. The IP address is not an identity. It's just a location. And I think that's something we have to fix, because this overloading of the IP address causes lots of problems. And I think complexity can affect our ability to reason about systems. So there's definitely a security concern here. And I think anytime you get a system where you add security as an afterthought, you're likely to encounter problems. And I think the internet is a brilliant example of security being a bolt-on. And it gives us entire classes of attack to have to contend with, from information disclosure through to things like credential stuffing, brute force attacks, and zero-day exploitation against systems that probably should never have been on the internet in the first place. But there's another problem that's bred by this complexity. And I think that's the heterogeneity of networks. The bigger and more diverse private connectivity becomes, the more amplified this problem and the more opportunity for change mistakes to creep in. And we start to see this sort of siloed complexity emerging. So, would you use the same tools to configure and connect pods in your service mesh together as you'd use to gain management access to your devices, as you would to perhaps get remote access then to your Raspberry Pi from home, as you would to a serverless Lambda function or a sensor, an IoT device on a 4G network somewhere out in the field? And so we end up with all these different ways of building secure connectivity that I think only exacerbates the problem. So this is the sort of the complexity and micro adjustment that I think many of us are probably familiar with from the last 30 years or so. And I think this is really a representative of where we've come from in terms of networking. It's always been very manual, very laborious, very micro adjustment oriented. It feels to me a lot like it does to drive a vehicle. And so today, most of the vehicles on the road are a parallel of this networking paradigm, where we have to be responsible for the controls of the vehicle as we drive. And that creates, I think, a problem for us as operators, because it means we're not free to do other things. But there are all sorts of ideas swirling around us, from autonomous vehicles, where actually the tool only cares about the outcome. From the operator's point of view, the operator tells the tool, drive me into the center of London. The operator doesn't actually have to command and instruct the tool and make those micro adjustments. And I believe that networking today, it's too complicated. And I think that network security is also too complicated. I believe that there's a trade-off that most of our tooling forces on us to choose between either security or convenience. And I think that's wrong. And the other point that I want to make here is that please don't think of what I'm getting to here as managing complexity. It might sound like we're just thinking about, okay, how do we put tooling in place to manage this complexity, to automate the access control lists and the accesses? But that's really not what we're talking about here. And I think there's a whole bunch of complementary ideas in the industry at the moment that we've already kind of embraced without maybe really thinking too much about it. Actually, I call these promises. So to me, DevOps is a promise to go faster. Self-service is a promise for more autonomy. Infrastructure as a code is a promise for increased reliability. Chaos engineering is a promise to be more resilient. And zero trust network access, if you haven't heard of the term before, is a promise for better security. But if you dive into any of these ideas, these promises, take DevOps, for example, it usually starts at culture, which is why we've represented it here as a pyramid at the top of the organization. And it trickles down through the people, the process, the tooling, this idea of going faster. And eventually, you butt up against the network. And if you're an organization that has something like 60,000 firewall rules, and there are organizations like this, and that's a real extreme to draw the parallel out, but that can be a real problem if you've put all this other business transformation in place, and then you still hit up against the network. So how can we go from the chaos and the fragility of an address-based network, something like this, to an identity-based network, and why would that be better? As I said before, I think we're used to tools that attempt to manage this complexity, to absorb it. And I think to an extent that can work, assuming that your management tooling can handle all of those overlapping circles in the Venn diagram I showed earlier. But it feels like a losing battle to me. I think you can only get so far in trying to abstract this complexity. I think at some point we need to say, right, we're going to remove the complexity, not manage it. And I think that's our opportunity to think about new tooling. And I'd start by taking us towards this idea of zero trust network access. And maybe not everybody has heard of zero trust network access before. So I just want to remind people, and apologies if you already know this, what the key principles of zero trust network access are. But effectively, we're saying that our applications should be, by default, hidden from the internet, hidden from discovery. We should have something somewhere that verifies access before it's allowed. And we should do that not just based on the network location, but the identity of the access. Lateral movement in the networks should definitely be prohibited. And that should lead us to a reduced surface area for attack. So that's what your network might start to look like if you use tools that put identity first. And actually, there are a lot of ways of building a zero trust network access website, a zero trust network access network that fundamentally puts identity first. Different architectures, different vendors, and there's a much deeper exposition on this website. You can scan the QR code from your phone if you're interested. But I'd like to focus in on one specific architecture, which we call a zero trust overlay network, where we effectively say, right, we've got our existing network and it's really complicated. And what we're going to do actually is build a new virtual layer on top of the one we've already got, an overlay network. And I think this is a super interesting architecture to build an identity-based network from, because it has all sorts of interesting properties that just emerge without really having to try. So this kind of an architecture, it doesn't need open firewall ports or ingress traffic on the actual network itself. The connections are established directly between participating systems, not via a middle box or a VPN server. And it doesn't really care whether or not your traffic is moving north-south, like a remote access traffic pattern, or east-west in the service mesh. The underlying network there actually becomes kind of irrelevant. And it's interesting because when you combine these principles, the network doesn't actually need to, the underlying network doesn't need to be changed in order to create or tear down private connectivity. In all of the other architectures that you'll find listed here on this website, we still care somehow about the IP address, the fundamental network. But in this architecture, that just becomes part of the plumbing. We don't really care about that complexity or those network addresses anymore. We're more focused on the identity, but we're also not having to open ports, not having to run appliances. And so the perimeter of your network kind of starts to go dark to the public internet, and it makes your infrastructure much harder to discover. And if it's hard to discover, it's hard to target, and it becomes harder to attack. And the other thing that's interesting, I think, about this particular architecture is that it also gives us the same set of promises we strive for in those other ideologies that I mentioned earlier. Because connectivity is direct between our systems with only outbound traffic and no changes to establish the overlay network, you get to mutate the network super quickly. In under 100 milliseconds in most cases with this architecture, you can just express a change in the topology and the network just automatically changes. And it can be a really fundamental change to the topology of your network without actually having to make changes. And it's a really strange concept the first time you hear about it for some people. You can automatically form private networks, which means more autonomy for teams by decoupling those teams from the need to worry about how does the private network get built in the first place. Because there's no change, your configs don't drift, your firewalls are always closed. It means increased reliability because we're not changing the network anymore. And we become more resilient to failures because there's no traffic concentrators like VPN servers to go down, because traffic moves direct between systems and devices, always taking the fastest route. So you kind of get diverse routing for free. And as I mentioned, there's no open ports on the actual infrastructure itself. So you end up with better security. It's a way of moving from being a reactive to proactive, because the ports aren't open. So you're preventing that class of attack that we had before, which started with reconnaissance and potentially ended up in zero-day exploitation by third parties. So we don't have a great deal of time in this session, so I'm not going to dive too deeply into exactly how this works without opening firewall ports and things like this. But what I will do, Luca, if that's all right with you, is I'll hand over to my colleague Alistair, because he's got a demo lined up, an example of the kind of things that you can do if you move away from address-based networking towards this idea of an overlay network architecture coupled with the ZTNA principles.
That is definitely right with me. There are a couple of questions in the Q&A that maybe we can get to before we jump into demo. Can you see them?
Yes.
Feel free to read them out.
It might be that it might make more sense to save some of the questions till the end.
Yeah.
I'm not sure if these are quick to
problem.
answer or not quick to answer questions.
Let's jump into the.
Is that all right? I suspect Alice's demo might answer some questions as well. And whilst Alice is running his demo, I can read the questions.
Perfect. Let's do it.
Okay, hello everyone. Hi, as Mark said at the top of the call, I am Alistair. I'm the CTO of Enclave Networks. And I'm going to, as much as Mark set the context for what Zero Trust Network Access is and identity-based networks and overlay networks, I'm going to try and give you a little tale that maybe puts this into a more concrete sense. So I'm going to tell you a little tale of Big Corp, a tale of network change. So Big Corp have a application. It's not a super complicated application. It's in Kubernetes. They are using AWS EKS. So they've got an EKS cluster running in EUS2 in London. They've got a app pod, 2 replicas, got a database, another pod, and they've got some users, Alice and Bob, sitting on their home network, connecting via a VPN on the edge of the VPC to get into that app. And so far so good, right? It works, right, in classic terms. And then we want to introduce some change, right? So we're seeing some attacks against the VPN itself, right? So how do we stop bad actors attacking the VPN? So maybe we add IP address ACLs on the firewall in front of the VPN, right? So we say, we know Alice is public IP, we know Bolt's public IP. So we put an ACL on the front of it, right? And say those IP addresses are allowed in. Now, obviously, that's a bit of a pain because, if Alice goes to a coffee shop, then she doesn't have access. If we add a new person or someone leaves, we have to mutate those rules quite frequently. So that's not ideal, right? It is, maybe it's workable, but it's not ideal. So we get another question, right? So another change. Bob is a developer, right? So can he get access to the Postgres admin tools inside that EKS cluster? Yeah, maybe. I mean, Bob, we could maybe figure something out here, like maybe route them through the VPN, maybe set up another rule. It's going to be complicated, but maybe we can sort something out. It's already starting to get quite complicated, but no, maybe it's still manageable. Now I tell a scary network admin story, right, from the people that have done this in the past. So we're going through a merger. Big Corp is merging with Small Corp, right? And Small Corp have a separate Postgres DB, right, in addition to the ones Big Corp already have. We need that app in Kubernetes to talk to that server. Oh, and if I haven't mentioned already, that server is on-premise. It's in an office in Virginia in the US. There's no IT team at Small Corp. The server runs Windows and the server can't move, right? As depicted by the excellent screen painting, this is kind of a nightmare. So how do I do this, right? So I want to get a connection from right inside my Kubernetes cluster all the way out to a completely different box in a completely different network that is not connected in any way, while still maintaining all the existing setup that I have, right? And then even now, like, I've only made 2 changes and already this network is starting to get complicated, right? But let's imagine like moving this towards this identity-based networking, zero trust network access piece. And think like, what if we didn't have any perimeters? What if there were no network perimeters? What if we just had Alice, Bob, our app replicas, our current Big Corp replicas, and this Small Corp database on Windows over in the US? Right, so now it looks really simple, right? But we haven't actually done anything with that. What if we could then define our connectivity for those by a business requirement rather than by IP addresses, right, as we would have done in the old world? First up, we would maybe group or tag our systems so we can identify them and manage them within our network. So I've tagged Alice as a user, Bob, who's the person that wants to be able to access the Postgres admin tools, is a developer. I've tagged Kubernetes app on my app cluster. I've tagged Kubernetes DB on my Postgres instance. And I've got a tag external DB on this Small Corp database over in Virginia. Right? So what connectivity do we want, right? So identity-based networking is, as Mark said, about defining what you want to achieve without having to worry about how we achieve it, right? So we like to express this via policy, right? So let's just say I've got 4 policies to make all this fit together. I've got users and developers can talk to Kubernetes app. The Kubernetes app can talk to our Kubernetes database in the same cluster. Our developer can also access the Kubernetes database. And now I want to add a policy for the merger that says Kubernetes app can access the external database.
I think we might have lost Alistair's network connection there.
Okay, I thought it was me for a second.
No, actually, his network connection's been a little bit
Bob can access the database. Everyone can access.
So that might make the
existing database
the most uncompelling demo.
We can still now
maybe we can try to. Okay.
Yeah, so I'm happy to. Alice will just restart his network equipment, and I'm sure he'll be back on with us in a few moments. We'll be happy to pick up that demo. But in the meantime, Luca, I can certainly answer one of Adil's questions.
Yeah.
So
Alistair, you're back. Can you hear us now? No. Still
No.
a bit like.
Sorry, I just changed network connection. So this is a classic thing that happens, right? Yeah. I could actually get you guys on, but
classic lag
fine.
demo. Yeah,
I'll,
I think there's
get
a
back to
little bit of
sharing
lag.
of
But yeah. Go ahead.
Okay, cool. Hopefully I'm back with you. So I don't know where I lost you, but I believe I was probably on this slide at the time. So yeah, once we've got these policies in place and we've identified our systems, we end up with this desired network, right? Where we've got identity involved, we don't have to worry about the perimeters anymore. And we can apply change without it causing us a load of extra IP address changes, VPC changes, all of that stuff. So, let's actually do something concrete, right? So what I'd like to do is I'd like to do this merger in Terraform, and I'm going to do it now on the call, right? And we can show how easy it is to actually mutate identity-based networks in code. So we've got this small core database over here, right? And I want to bring this into this app and do this little merger. So I have designated a Postgres server that this is small corp's Postgres server. It is in an annoying office in Virginia that doesn't have a great IT setup, and I want to be able to bring it into my existing cluster. So I have got a Terraform setup that creates this existing network, right? Creates the big core network setup, minus that database server I've just pointed to, which is the small core Postgres database. I've got the enclave agent running on my local machine, right? And you can see I've got a couple of connections here to systems on the virtual overlay network. I'm also logged in as a test account to Azure AD because I've got my big core also has a requirement that all this connectivity can only happen if people are actually authenticated as per zero trust principles. These systems down here, they've got very Kubernetes-like names. That's because they are pods running EKS. And the EKS setup is very basic. Right? It's literally pods have egress access, fairly default VPC settings, just no fancy VPNs, no open ports, something like that. And I've got this application running. This is in Kubernetes. So this is running in EKS. I'm not VPN in EKS. I haven't exposed this application to the public internet, but on apps.bigcorp, because Enclave does DNS for you as well, I'm now accessing that application directly, right? You'll note here that I've got posts, so this app sort of connects to the Postgres database, right? And just checks, is it up? What's connected to it? And you'll notice I'm connecting to a DNS name of my choice. And I'm getting addresses on the virtual overlay network, right? I don't actually have to worry about these names, these IP addresses at all. Again, it's not address based, but I'm just revealing that to show that we are not connecting on the normal network, we are connecting on the virtual overlay. Okay. So now I want to do that merger, right? I want to switch this app and I want it to connect to that Postgres database that I pointed to you before, okay? So let's set up for that. Let me go back to my Terraform setup over here. Okay, so I'm going to just start spinning up a new section of config. And I'm going to call it
Oh dear, we lost Alistair again.
Yeah, I think we did.
So perhaps
I'm trying to mute him.
To the PowerPoint presentation. You'll remember I have this identified box here, it's external D tag. So I'm going to create that tag to let me identify these systems.
Back.
I wouldn't be so sure.
I mean, I can still hear you, which is a really frustrating thing.
So you actually are coming through more clearly now, Alistair. Although you're no, he isn't. He's gone. Okay, fair enough. Alistair, do you want a moment to reset your internet connection? And while you do that, I'll answer some questions.
Yeah, that's probably a good idea. Why don't you do that, and I'll jig things about a bit.
Great. Okay.
Let's do that. No problem.
Fab. Okay. So I'll go top down. So the first question that Adil asks is: Would you agree with the truest attestation of workload identity? The flaw in the common view of defense in depth is further pronounced. I'm not entirely sure I quite get what Adil is asking there. So I'll move on to his second question, because I think I understand that a bit more clearly. What you're asking, Adil, is surely zero trust as a concept assumes that the private network is already compromised, at which point, why bother with segmentation? Why not just have a flat VPC and a flat subnet? I think, to be honest, I actually think that's a pretty fair point. I suppose one of the things that I find slightly frustrating sometimes about our industry is that I think sometimes we can be perhaps a little too literal, sometimes a bit pedantic and dogmatic about some of our ideologies. And I think, to me, zero trust is not that useful if we take it in that literal sense, because I think it's caused a lot of people to stop and question it if you take it a bit literally. So I'd be more tempted to think of zero trust as more of a shift in our mindset. Instead of assuming that our networks are a bit like a hard shell with a squishy center, perhaps it makes more sense to move our security controls closer to the assets themselves rather than hanging them out on the perimeter. And obviously, you need to choose the right tooling and architectures that work for you and your organization and what your organization is doing. But I'm not sure I take this in such a literal way. I'm not sure that I would say that, look, this is, moving from implicit trust means that we should remove, or rather moving from implicit trust to explicit trust. I don't think that literally means that we should remove all of our security controls. I think, to me, this is, like I say, about a shift in our mindsets, about minimizing our attack surface and lateral movement, and not necessarily something to be, really pedantic and dogmatic about. For what it's worth, I think we'll also start seeing a much tighter integration between vendors. So think about endpoint detection and response, EDR and XDR, and similar tooling, detecting endpoints whose security posture moves out of a state an organization might consider healthy. Well, then that system is sort of clamped down, but an integration with your ZTNA tooling means that not only is the system sort of locked out from the user's perspective, but it also is dropped off the network. And so, to my mind, an architecture like the one that we're describing here, it feels much more like, instead of saying, hey, we've got this site-to-site VPN and any traffic that comes across it is just trusted, we're taking a much more shrink-wrapped view of what needs to talk to what. So no, I'm not sure I'd agree with the idea that if we accept zero trust as a concept, then we should move to flat networks and VPCs. Brian, well, actually, Alistair, you're back. Do you want to resume where you were?
Yeah, I believe I am back. I've changed my network around, but it networks, right? Okay, let me just go back to this. You guys can see that VS Code instance?
Yes, we can.
Okay, so where was I? So we want to define this access, this Postgres box running in the US. And I'm just defining a tag in Terraform in the enclave network, external DB. Then I need to define something to get that system into my network. And for that, I'm going to define an enrollment key. Enrollment key is more or less, it's a token or / a secret, depending on its properties, that says, this system is allowed to come into my virtual network. And I'm setting it up so that anything that comes into the network via this key gets tagged with that external DB tag. And I'm also outputting that key so I can copy it and send it to the guys at Small Corp and get them to enroll in the system. The next thing I'm going to do is I'd like DNS for it, right? So I'm going to declare a DNS zone on that overlay network, Small Corp, and I'm going to declare a DB name, right? db.smallcorp that I can use to reference anything with that tag. Finally, I'm going to go over to my policies file, right, which is where I'm storing my policies for my network. And I've got sort of these 3 policies so far, which define the existing connectivity between the systems. And I'm going to add another one, right? So this policy says web apps can access external Postgres, and it connects the systems tagged with Kubernetes web app with that tag I've just created saying external DB, and it allows Postgres traffic. Okay. The final thing I'm going to do is say that policy. I'm going to go to my app configuration. I'm just going to change a setting inside it, right? So this little demo app container I've got in my Kubernetes container specifies a config that says where to go to connect to the database. I'm just going to point that app instead at the external DB. Right? So that tag, that name that we just created a second ago. And with that, I am going to then bring up a terminal and I'm going to run Terraform apply. I'm going to give it a second to figure out the plan. And that is extremely amusing because I have turned off setting. 1 second. So I need to make that sensitive as true because that key is sensitive. Again. Okay, so this is going to prompt me for all the changes, but most of this is just changing stuff on the overlay, right? I'm not actually changing anything here on the underlying network. I'm just setting up the overlay changes. I'll make that change. And as it re-provisions servers, you'll see that the systems I'm connected to via the enclave agent mutate as well, as Docker, as a Kubernetes brings up and brings down pods. Wait for it to complete, even though I think it's probably already done. I'm pretty confident that's what it's done. I'm going to just jump to the web browser and believe that it's complete. Okay, so in a moment, this application should be available to me with the updated config. I probably should have waited for the Terraform state was done, shouldn't I? Okay. Here we go. Classic demo. Okay, I don't think I made a mistake on that policy. Just double check the policy again. So we are sending Kubernetes web app traffic to the external database. I have got, if I look at my enclave agent, oh, sorry, no, I know I've missed a step out. So I set up an enrollment key for that external DB, and now I need to send that enrollment key over to someone in Small Corp and get them to enroll the system. So I'm going to grab that external DB key. This is what I've got. Okay, and we'll just go grab that. I'll go back to our server and pop that in there. And then we'll enroll it. Okay, and then that's going to basically bring it into the network. And because I've already defined all the policies, as soon as that connectivity comes up and that is set up, I should see the connectivity to the app come up pretty much immediately. Okay, there we go. So I can see on this side that I've got this network and this app is now connected. And then if I jump back to the application, if I'd actually completed all the steps originally, I can see that I'm connected to this db.smallcorp over the enclave virtual IP. It's got a way longer latency, right, than the other one. Right? The previous latency on that query was like 3 milliseconds. But now, because this server is in the US and this is in London, the app's in London, it's got a longer, much longer latency. But in just that time, allowing for me forgetting to enroll the actual server, we've now got this connectivity between all of these nodes. That's it, right? I haven't actually had to do anything else to bring that connectivity up. And because it's Terraform, it's all infrastructure as code, I can turn this on and off, I can bring policies up and down in exactly the same way as I would anything else. That's pretty much it. Merge big corp to small corp merger complete, in quotes. I think with that, I better hand over to Mark just to wrap up and give us time for answering any final questions.
Fab, thanks, Alistair. I will share my screen again, Luca, if that's all right.
Absolutely.
So what Alistair's shown really is a view of building zero trust network access based on an overlay network. And we are by no means the only people or company or vendor in the space that are doing this. I pointed to a zero trust network access.info microsite earlier that we've pulled together to help make sense of what is effectively a very new and very dynamic industry. And I think what I'd like to convey, if you take anything away from this talk, not only is this a new and emerging technology, which means that right now, for a lot of organizations who are adopting this stuff early, it can be a bit of a differentiator and a competitive advantage for early adopters because it allows you to step away from constant micro adjustments to the network. And the other major point that I'd make, and apologies to anyone who doesn't get the reference, but I feel like very much we're in the blockbuster age for manually adjusted networks and VPN servers. And realistically, you've probably got better things to do than stop and make micro adjustments to your networks just to enable you to do something else. So I think in summary, next time you have to think about IP addresses as you're trying to arrange private connectivity, stop, because there's probably a better way of doing it. And that's it. So we can answer some questions. And I would say a huge thanks to Alistair and Luca and the rest of his team, Human in Tech, for inviting us to present this evening and for organizing it, and to everyone who's showed up to listen to what we have to say and to ask questions.
Thank you, guys. This is great. Yeah, let's get to some of the questions. So Brian was saying, Zero Trust also assumes that developers are performing adequate identity management already. Does it not? Seems to me that a hybrid approach would allow for a secure solution, but one or the other alone makes no sense based on how many databases I've found in my time that have no authentication.
Yeah. Well, yeah, I mean, this is the big flaw in tooling, isn't it? If we don't use it, just because we can apply security doesn't mean that we'll use it. I think MongoDB made this quite evident a little while ago because they shipped a tool that listened on 0.0.0.0, and a lot of servers had public IP addresses. And so a lot of them ended up being used in DNS application attacks, not DNS. I think the Mirai botnet, one of the biggest botnets, when it was active, it was the biggest botnet we'd ever seen, and it was scanning the internet for IoT devices that ran on the ARC processor. So to me, I think it's really easy to get lost in this theoretical conversation about, is it zero trust? Is it not zero trust? Should we do it this way? Should we do it that way? And I think the answer is ultimately, if it works for you, do it. If it doesn't, don't. I think there's value in taking things off the public internet, putting the sort of the really rigid dogmatic view aside of what zero trust is or isn't. I personally think that if your ports are not open, fundamentally open, I think that puts you in a better place than you would be if they were.
There's an interesting threat going on between Fred and Adil. I don't know if you guys have anything that you want to chime in there. Maybe you can take a moment to go through that. I'll read out the next question, Valerio. So assuming I'm implementing least privilege and my egress is narrowed down to the minimum. In this case, if I need to join machines, pods, databases to an enclave, is there any IP or I don't know what that stands for, to be honest.
Fully qualified domain name.
Right. That I should consider to whitelist an egress or anything else? What are the network requirements?
Alistair, do you want to take that, or shall I?
I can. I can take that. So it's an interesting question, right? So connection into the enclave virtual overlay network is controlled by this trust broker component, right? The need to sort of whitelist the list of IPs is there, but it's there mostly to allow you to ensure that if you lose enrollment keys, especially enrollment keys that grant access to quite secure parts of the network, that only systems where you expect, like, an AWS data center or your office or whatever, are actually able to reach into the network. In reality, once you actually enroll the system, the location of the device becomes irrelevant. Right? The actual where it is becomes very unimportant. There are mechanisms there to protect against people stealing cryptographic material by moving it from one system to another. But in reality, no. I mean, once you've enrolled things, it doesn't really require additional protections. You would need to, as I said, we have a trust broker, which means that you'll need to be able to provide access to the trust broker. So any egress connectivity will have to allow access to the trust broker. But beyond that, that's pretty much it. The important thing is to make sure you manage your enrollment keys correctly, and once you are enrolled, the rest the overlay network kind of takes over.
And I'm also back. My network also died for a second. All right, Casper's saying, great demo. I liked how easily the elements got connected. And the example, the policies were limited, of course, but how would it work with the 60K firewall example of a big corp? What would you do to prevent the policies file from becoming unmanageable?
I think
there's probably two answers to this question, right? There's my brief answer, and probably Mark has a more interesting answer. So, because it's Terraform, you can organize your infrastructure like you would any infrastructure, right? Break it into separate modules, have it managed by separate teams. Because you're all sharing you're all connecting to the same enclave overlay, you can still micro-segment within different Terraform modules as long as you're using the same enclave overlay network, right? Because we default deny, you can separate out your policies to different teams and different parts of the business, and they will microsegment automatically because you're creating separate sections of connectivity for them, right? I would suggest, separate repositories or separate Terraform blocks for different teams. And if you need to bridge them, you can, right? Because if you want to set up a policy between teams that allows them to talk, then it takes moments rather than, having to go back and forth and change lots of AWS settings. There may be a more general answer to that about how you avoid having those 60,000 firewall rules in the first place, which Mark might want to speak to. But from a practical level, that's probably how I'd manage it.
So I actually think that is an awesome question.
Yeah,
I don't think this is ever going to be free, right? If you're in an organization that has network complexity, it's probably because you're in a complicated organization as well. And so I don't think this is ever going to be free. I don't think it's ever going to not require some management overhead. And to me, this is about what Alistair's talking about there is can we introduce practices to segment responsibility and keep the things that we do have to manage more easily reasonable, making sure that things stay easy to reason about. And I think if you're able to take away a lot of the cruft of IP addresses, subnets, access control lists, network security groups, VPN servers, firewall configurations, port numbers, all of this kind of stuff, if you can take that away, I think you've already made a complicated task a bit easier. And I think particularly with this specific architecture, my personal view is that it lends itself quite nicely to incremental adoption. So maybe you bring on a handful of hosts, and that takes away a handful of ACLs. Maybe you bring on a handful more hosts, and it takes a handful more ACLs away. And ultimately, hopefully, you have a much simpler underlay network that's easier to reason about. And you're just dealing with policies that express the complexity of the organization that are also easier to reason about. But I think, this is an emergent technology, and I think it as a concept has a long way to go. I think there's a lot more opportunity for innovation in the space. And to me, this is a super exciting technology, because I find it really hard to imagine going back to the old way of doing things. And of course, I would say that I'm biased, but there we go.
Nice. Nicholas. Oh, and Nicholas, by the way, apologies for the. I think I fixed the Q&A, the chat thing in the settings, but we would have to probably start a new webinar. Nicholas asking, what is the performance overhead?
I can probably fill that one. Yeah, so I mean, we specialize and put a lot of focus on making Enclave as lightweight as it's possible. So the Enclave agent is Enclave is a small application, consumes maybe 50 meg of memory as like a typical usage on normal usage. If you have servers that are handling 900,000 connections simultaneously, then that memory usage will go up. But we're not looking at it to go up by much more than maybe a meg every 10 connections or so. Right? We are focused on keeping this footprint low and letting you use your normal your normal operation should just be able to continue without Enclave being a real drain on additional resources in your network.
Don't forget, of course, that a lot of the memory there that Alice was talking about comes from operating system allocations for the TCP network stack.
Yeah.
As new connections arrive. And kind of interestingly, if you do a search on Google for UDP performance and C#, I believe a post Alistair wrote is at the top. So at the very least, Google thinks we're an authority on writing performant code.
I spend a lot of time on it, let's put it that way. Yeah.
Cool. Steve's asking, is this a peer-to-peer connection? Does it require an agent on both ends, or can it be also used for SaaS services such as Azure App Services?
So it is a peer-to-peer connection in almost all cases. There are some networks that are quite restrictive in which we relay through a service that we control. But because all the data is end-to-end encrypted anyway, we still don't see that relayed traffic. It's like a transparent switch in that sense, right? With the encrypted traffic moving on top of it. But in almost all cases, peer-to-peer. And Enclave is quite good at finding the most efficient route between servers. So if two servers are sitting in the same building, then they will probably be able to get a really efficient LAN connection. If one's in Azure in the US and one's in a really locked down network in government in the UK, then maybe it'll have to relay. But primarily, we definitely seek to go for a direct peer-to-peer connection. There's a second part to that question, but it's vanished now. So it doesn't have to require an agent on both ends, but the use of Azure App Services is quite an interesting one, right? And it's like another facet to this whole problem, right? We have a functionality called exit nodes that allows you to sort of break out of the Enclave network. But fundamentally, Enclave is for accessing private services, right? Things that are private. You can constrain Enclave to, you could set up Enclave to constrain access and route access to Azure App Services. But things can get a little complicated because of the size of the IP address space that they use. And as soon as you drop out of the Enclave network, you then lose a lot of the microsegmentation and zero trust properties that you had in the first place. So the answer is, in a way, but we are working on better options to do that. And there are other alternatives to, route. It's not like an old full-tunnel VPN. We route everything through VPN and it becomes your internet concentrator, right? It's a very different architecture. But it is something we get asked, right? So we are evolving our answer to that question as we go, really.
Yeah, Steve, you'd be very welcome to catch us on our Slack channel at some point. I'd love to have a conversation with you about that and see what you're thinking.
All right. Valerio is asking, are you planning to partner with major cloud providers?
Yes. Yes, we are, Valerio.
Nice. Any timeline for that?
Probably within the next 2 or 3 months, we'll have something alive with AWS, and we'll branch out from there.
There's a question by Fred. I'm not sure what he was like responding back to a deal.
I think so.
Oh yeah, all right, got it.
Yeah, I agree with Fred. Actually, I think the whole point of this, in some respects, is that it really doesn't matter if the traffic is kind of crossing a network boundary or not, whether there's this idea of internal or external. I think, to me, that kind of belongs with the address-based networking, the old way of doing things, where we're kind of picturing, where is this, where is that? Is there a different trust level on either side of this boundary? I think that's not a helpful view of our workloads and our apps. So yeah, I agree completely, Fred. I don't think it's about internal or external. I think it's about removing that distinction altogether.
Awesome. Guys, we went over already like 10, 15 minutes, but this was great. Plenty of questions. So many people that stuck around until here. So I think this speaks to the quality of the content. So thank you for joining us. Apologies, everybody, for all the small little technical glitches that we had today.
I'm just going to go throw some network hardware in the bin.
But that's when you know it's live. It's a beauty.
Yeah.
All right. Sweet. Thank you so much, guys. Appreciate it. And thank you, everyone, for sticking around.